So I want to find all the inflection points of this function. Of this function here. If any. Okay, so pay attention to that. It says if any. There might not be any inflection points. We don't know that. So we have to find out if there are any inflection points. So what I'm going to begin with is I'm going to take the derivative of this function, right? So I'm going to take the derivative of it first, right? So I'm going to do y prime of this function is going to be equal to 4 times x to the 4 minus 1 cubed plus 0, right? Okay. Then I take the derivative again, so we have y double prime is equal, in order to get to inflection points, I have to find points where the second derivative is equal to 0, or where the second derivative is undefined. And of course, so I need to differentiate twice. So here it is. So I have to take the derivative again of this. So I go 3 times 4 is 12, x squared, and of course, nothing. Yes? So now what I need to do is I want to find points with this expression over here, with this equals to 0, right? 12x squared. So I say 12x squared equals to 0. Now that implies, if 12x squared equals to 0, okay, that implies that x squared equals to 0. And therefore, we have that x is equal to 0. So what we have here is that the only possible inflection point is x equal, or rather the only possible value of x that leads to an inflection point is x equals to 0. Okay, well, unfortunately, we're not done, okay, because we still have to see if we have an inflection point when x equals to 0. So what I'm going to do is I'm going to create a real line. Okay, so I'm going to create a real line here. And then what I'm going to do is I am going to plot, let's say the value is 0. Let me just add a color for that. I'm going to plot the value 0 right here. So now the domain of this function up here, x to the 4 plus 3, y is equal to x to the 4 plus 3, because it is a polynomial, it's all real numbers. So note, okay, note domain of the function y, f of x, or f of x equals x to the 4th plus 3 is all real numbers. All real numbers, right? Since f of x is a polynomial. Okay, so I am going to take the alleged x coordinate for the inflection point, x equals 0, and using that alleged coordinate for the inflection point, I am going to break the domain of the function f of x into a union of open intervals. Okay? Not actually the whole domain. I'm going to take 0 out. I'm going to extract 0 from the real line, and I'm going to be left with 2 open intervals, which I'm going to write right now. Okay, so the first open interval that I'm going to get is negative infinity, 0. The second open interval that I'm going to get is 0, comma, infinity. Okay, so clearly the first interval is right here. Sorry, I forgot to do this. And the second interval is right in this piece of it. So now what I have to do is I have to find a value in the interval negative infinity to 0. So I'm going to choose the value negative 2. I'm going to choose the value -2. So if I choose the value -2 and I evaluate it into y double prime, so y double prime evaluated at -2, I can choose any value, is going to be equal to 12 times 4. Now that is a positive number, okay? Because that is a positive number, that implies that the graph of this function, y equals x to the 4 plus 3, is concave up in that open interval. Okay, so it implies concave up. And in fact, it's concave up in the whole open interval. Now I have to do the same for the interval between 0 and infinity. So I'm going to choose a value. I can choose any value. I can choose the number 3, I can choose the number 2, so on. I cannot choose the number 0, so of course I'm going to choose the number 2. So I'm going to go y double prime of the number 2, right? Again, this is equal to positive. So this implies that in this whole interval, okay, the function y equals to x4 plus 3 is concave up. So this implies, okay, that this is concave up. Therefore, we have to conclude, thus, okay, so the conclusion is, thus, we don't have, okay, an inflection point. We don't have an inflection point, although the second derivative was equal to 0 at the point x equals to 0. Anyway, thank you for listening, and I'll see you next time.